So today we are going to integrate the Gaussian curve from negative infinity to positive infinity. So this is a cool challenge and everybody knows how to do it, but it's a nice integral to compute. You can do lots of tricks with this integral. The way I'm going to do it is just the more known way. So you just say that this is a constant, for instance I. Then we can also say that I is the integral minus infinity to infinity, but now write it instead of with x, write it with y. And now you can multiply both of them. And we'll say that I squared just be integral e to the minus x squared dx times integral minus infinity to infinity di squared. So now we can just put the integrals inside of one another. So we will have this and now we can do the trick of changing the coordinate system to polar coordinate system, but in 2 dimensions, which will be the double integral of e to the negative r squared, because x squared plus y squared will be r squared. Then the Jacobian will be r, then the r is theta. And since we were integrating from minus infinity to infinity, which is the whole plane, here in polar coordinate system, the r will go from 0 to plus infinity, and the theta from 0 to pi, which will result in, well, the integration in theta will be just 2 pi, because we don't have any theta in here. And then we will have e to the negative r squared, and then if we differentiate this, we will have the r, and then the derivative of this will be negative 2, so we have to divide to negative 2 and compute this from 0 plus infinity, which will give us just negative pi times e to the negative r squared computed from 0 to plus infinity. And now it's computing the limit e to the negative infinity gives us 0, and e to 0 gives us just 1, and this is just pi. So now we know that I squared is just pi, which means that I is just square root of pi. The positive one, because this function is always positive, so the integral is positive, so this is equal to square root of pi, and we have to ensure that it's greater than 0. Yeah, so this is how it's done.